So, recalling our days in chemistry and in physics, if we've taken both of those courses, dimensional analysis is a hugely important component to performing calculations in science. The same is true in engineering. And so the two categories, previously we looked at making sure that we get the correct numerical value to our answer, so significant figures. But then we also have to make sure that we're getting the correct units. And a lot of times, especially in problems where we aren't terribly familiar or have an intuitive sense as to what our numerical answer should look like. We just don't know, based on the parameters of a given problem, what our answer should seem to numerically seem to be. If we are paying close attention to our units, it can oftentimes be really helpful to kind of reassure us that we've ended up in the right place with our answer, even if we don't have an intuitive feel. So for starters, in the SI system, we can see for all of these various types of measurements, we have a fundamental measure that we use. This is certainly, there are many ways that we can measure length off of the meter, besides the meter, so centimeters, millimeters, kilometers, but the meter is the fundamental length. Likewise for time, we can do minutes, we can do hours, we can do milliseconds, but seconds is the fundamental measure. And you can see the rest of them listed in front of you there. The one that we'll use we won't really see in this course is the luminous intensity, but all the others will show up from time to time. The one that I'll make sure to point out here that might be surprising, for mass, it's not the gram, it is the kilogram that is the fundamental measure. And you will be held responsible for knowing these. We're also going to be using English units. For those problems, you'll probably cry some real tears at times. But as I suffered learning these back in my day, so I pass along the suffering to you. In our first example that we see here, we've got the measure of the height of a horse. So we're told that our horse stands 15 hands tall, and so using the conversions that are given to us, we want to figure out how tall that horse is in feet. So to give ourselves kind of a systematic approach to this, for a dimensional analysis question, so we start off with the known measure of 15 hands, and then we're just going to multiply by a series of conversion factors. So we can go from hands to spans. So we've got 2 hands in the bottom, since we've got hands in the numerator in our original. So this will get us from hands to spans, Then we're going to multiply by the conversion that gets us from spans to cubits. So again, we're going to put the 2 spans on the bottom with the 1 cubit up top. And then finally, the spans go, we can get to from cubits to feet. So we put our 2 cubits on the bottom and our 3 feet on the top. And so we can see all of our units, just like regular numbers, cross cancel away. And so now we just multiply the numbers on the top, multiply the numbers on the bottom, so we end up with 45 over 8 feet, which if we divide that comes to 5.625 feet. But since we only had 2 significant figures in our original measurement, we can only have 2 significant figures in our answer. Our significant figures rules for multiplication means that we keep as many significant figures as we have in our original number. Since all of these were conversion factors, they don't factor into significant figures. So we're going to round off our answer to 5.6 feet. In the next example, we've got a little bit more going on with our conversion. I'll note that in my copy here I don't have the decimal point, which in yours you will. So we've got 3 significant figures in our original measurement, so we will have 3 significant figures when we get to our final answer. But we're going to start off with that 800 meters per second, and we eventually want to convert that into miles per hour. So we want to get miles over hours, And so that means that we have to convert the time unit that's in the denominator, and we have to convert the length unit that's in the numerator. So we can focus on the time unit that's in the denominator first. It's a little bit more straightforward there. So we're just going from seconds. We can go to minutes. So we can say that there's 60 seconds in 1 minute. And then we can take those minutes and convert them into hours. So we're going to multiply by 60 minutes over 1 hour. And so now our seconds cancel out, our minutes cancel out, and so we have the desired hours in the denominator of our units. So now we're left with converting the length from meters into miles. So the first conversion that we'll use is the one that's given to us here. So we're going to multiply by a conversion factor that gets us from meters to feet. So we need that 1 meter on the bottom, and then the 3.28 feet on the top. And then we've got to go from feet to miles. And if you don't know this one, you are a bad American and should feel shame, because there are 5,280 feet in 1 mile. And so just like we did with the time units, we've got the meters have been canceled out, converted to feet. The feet are canceled out, converts us to miles. And so now we've got miles over hours. And so if we crunch the numbers, multiply 800 times 600, or 60 times 3.28 on the top, divide by that 5280 on the bottom, we end up with 1789 points, and then it's 09 repeating from there, and that's miles over hours, or MPH. And then again, we've got to round off to the appropriate number of significant figures. And so since we had 3 in this original measurement, everything else is just a conversion factor, so it doesn't play a role. We can say that our answer is 1790 miles per hour. And again, no decimal point after that 0 in this case, otherwise we'd be indicating that that 0 is significant. It is not. We only have 3 sig figs, that's why we rounded off to the nearest 10. For the next one, again, one correction compared to what I have on the screen to what you have in front of you will indicate that we have 3 significant figures again, 1.00 cubic yards that we want to convert into meters cubed. So we start off with that 1 cubic yard. And so we want to go from, we've got this measurement up here from meters to feet. So if we can convert the yards into feet, then we can go from feet to meters and then get to that meters cubed. So I'm going to multiply this by a conversion factor that gets me to feet. So I've got 1 yard is the equivalent of 3 feet. But because those yards are cubed, I need this to be 1 cubic yard, which means I need cubic feet. So really what I need to do is I need to cube this conversion factor so that I'll have the ability to cross cancel the yards that I see here with the yards cubed in the original measurement. And then once we do that, we can convert from cubic feet to cubic meters using that conversion up above. So I'm going to go 3.28 feet to 1 meter. But once more, I need to cube that conversion factor so that I've got feet cubed canceling out with the feet cubed, and then the meters cubed is what's going to be left in the numerator. And so if we multiply that all out, essentially we end up with 27 in the numerator and then 3.28 cubed in the denominator. So if we round off to 3 significant figures from what we have in our calculator, we end up with 0.765 cubic meters, which should make sense to us if we think about it. A meter is a little bit longer than a yard, so that means a cubic meter would have more volume than a cubic yard was, or the flip side of that is a cubic yard will have less than 1 whole cubic meter of volume. In the last example, we're taking a pretty standard measure of acceleration, so this 55 meters per second, and we're converting it into a strange set of units, miles per hour per second. Now, under most circumstances, that's not going to be a very common type of unit that we're going to be looking at, But there are some specialty circumstances where, for some arcane reason, we have these odd units that come up as measures that might be necessary. And so we have to be able to handle these types of conversions in a systematic way. And so if we take our meters per second, and then if we rewrite our miles per hour per second, if we think of miles per hour, what that really means is we have miles in the numerator, and that hours is in the denominator, and then we already have the seconds in the denominator. So if we consider how are we going to get from meters per second squared to miles over hours seconds, what we're really looking at is two conversions that need to take place. We need the meters in the numerator to turn into miles, and for that purpose we've got the unit conversion that's given to us here. And then in the denominator, we need one of the 2 seconds to be converted into hours, while the other stays in seconds. And so that will be the two conversions that we'll undergo here. So we'll start off with our two significant figures in this case, meters per second squared. So we'll start off by converting the meters into miles using the conversion given to us. So we're going to have 1609 meters is 1 mile. So that takes care of the length conversion. And then we've got to convert one of those seconds that's in the denominator into hours. And so we could go from seconds to minutes and then minutes to hours, or if we know that it's 3,600 seconds to 1 hour, that will do the trick for us. And so if we push buttons on our calculator, we end up with an answer of 123.057799. It keeps on going from there, but of course we're dealing with two significant figures in this original measurement, so we're only going to have two significant figures in our final answer, and so that means we're going to be rounding off to the nearest 10. So we're going to have 120 miles per hour per second as our final